heard some wonderful thoughts. How many of you think you figured out at least the ones that are polynomials? Everyone agree? Figured it out. What is the pattern?
I don't know what a polynomial is.
Okay, well let's define that. What's a polynomial? What is a polynomial?
I meant scientific.
Many terms. It's a x squared, x cubed.
It's moved this for time.
Good. Okay. So everyone agree that we are moving the power down in front, multiplying by the power, and reducing the power by 1.
Yeah.
Everyone agree with that? Okay.
You have to count how many decks you have per cap.
I have 30.
Yes.
Well, 30.
Thank you.
You're welcome. Okay. So, what are the two?
It's gone.
There's essentially an x to the 0 power there.
Would you agree with that? There's essentially an x to the 0 power written beside it. And what's anything times 0? Okay, so it seems to work, right? So far. Well, so that means polynomials, we found a shortcut. We can quit doing the long way to polynomials. But I guess for something like 1 over x, you're still going to have to do the long way.
No, it's negative. Or
what? What did you say?
Is x to the -1 power?
Could you use properties of exponents and rewrite this as x to the -1? And then let's try it. -1 goes in front.
Yeah.
What's -1 minus 1?
-2.
Did it work?
Yes.
Working on that one?
move the 3 to the front.
3 to the front, drop the power by 1. So how do I do that?
X the negative 2.
Okay, -2 in front, x to the -3. Who did this one? How long did that take you?
Well,
It hurts your feelings a little. It's that quick, doesn't it?
we figured out the power.
Oh, okay, so then you got to cheat. This is not like a time saver. This is like a game changer, right? This is
So wait.
Take about 5 seconds.
How do you get over you?
Well, if it's -2x to -3, what's -3 power?
Why did you go to -3?
What's -2 minus 1?
-3. You just subtract.
Subtract 1 from the exponent. The exponent down, subtract 1 from the exponent.
But why wouldn't it be the x to the -3 then?
What
Flip it to 1.
what is -2 times x to the -3? The same as. So it turns out it's working so far. This little rule we have. That one's broken. Yes, I still need the long way.
No.
Okay.
Doesn't to the power.
If we know our algebra, this is x to the 1/2 power. Okay, let's pull the 1/2 in front.
Yep.
What's 1/2 minus 1?
-1/2.
-1/2.
That's a square root on the bottom.
Is that a square root on the bottom? How long did that take you?
That was.
It wasn't very.
Was it too bad? Was it as quick as doing what we just did? Okay, that one down here. This is 2x to the 1/2. Everyone agree? 1/2 times 2 is 1.
Subtract 1, -1.
Work. This one was bad.
Took a whole page.
Wasn't it? It was kind of neat. Maybe you'll forgive me. So that was really bad. Took him a whole page to work with. And there was a lot of room for error. Probably if you tried to do it, most of you would miss it somewhere and mess it up.
Trying to say Bryce is better than us?
No.
Because he is.
But he knew the shortcut and could check his work as well. But
No.
it was hard. You should see his paper. It was bad.
You can't read it.
So, let's see if the shortcut works. What is this as an exponent? X to the negative 1/2. Okay, bring the negative 1/2 in front. So f prime, based on the shortcut, would be negative 1/2 x to the negative 3/2. Where did I get negative 3/2? Subtracted 1 from the negative 1/2 minus 1 would be negative 3/2. This is x to the first power, right? This is x to the 1/2 power. What is 1 plus a half? 1 and 1/2, which is x on the bottom. It took him a whole page. Now there's some stuff that's a little tough. You got to know your properties of exponents. But was that hard? No. So you just learned what is called power. I will check it. Just come back. Like at lunch or something. So, if n is a rational number, what's a rational number?
I don't know. Anything that's not repeating. Or like,
Not repeating.
yeah, that's not.
The
Doesn't have a pattern.
The root word in rational number is ratio. What's a ratio? A fraction. It's something that can be written as a fraction. So repeating decimals like 0.3 repeating, well, it's a third, so that's a... So what's not rational? Things like pi and e, square root of 2, things like that. So power rule, if you have any rational power, we can use the power rule. X to the n is differentiable, and the derivative is nx to the n minus 1. So we just took problems that took us a whole page, problems that I could only assign you 3 a night, and made it into a 7th grade level problem.
Why is d over dx?
That is the other notation for derivative. Remember, there's the f prime notation and the d over dx, depending on if you're a Newton fan or a Leibniz fan. I had a video at the beginning I skipped if we have time. Later. If we have time. It's a Big Bang Theory, Newton. They were. Y'all will understand a lot more of their jokes now when they talk about Newton and Leibniz. That's an Einstein.
Miller's not.
You do not have to write all of this down. But there are some rules for derivatives that you kind of already figured out. If there's a constant sitting in front of the function, like 3x squared instead of just x squared, what do you do with it?
Multiply it by the...
You just multiply it by the derivative, right? So if you have 3 times x squared, it's 3 times 2x, right? Which is 6x. The constant multiple rule states that if there's a constant in front of a function, that function is still differentiable, and it's the constant times the derivative. Sum and difference rule. You figured this one out too. Remember there was an x squared plus something or minus something? Who had that one?
Got it.
X squared minus 5x or...
I think that was one of them.
We had 5x squared.
5x squared minus 3x. Couldn't you just take the derivative of the 5x squared part and the 3x part and add them together? You do them separately. That's what the sum and difference rule says, is if you have two things added together, you can just take the derivative of each piece and add them together. Same thing for subtraction. What you will know that is glaringly missing is a product and a quotient rule. Those are much more challenging because it doesn't work that way for a product and a quotient. So we'll have to work on those on a later date. So we don't have a rule for everything yet. But we have a lot of rules. A lot of things. Do what? So we're going to do 3, 4, 5, 6, 12 derivatives. Quickly. See how many of them you can do and how fast you can do them. Do you not know the rule, Miller? Okay, so you take the power and move it down in front and reduce the power by 1. So now constants were kind of strange.
First one is 0.
Yeah.
Yeah, I already got that done, Drew.
Well, you can now just memorize that the derivative of constant is 0. Which, think about that really quick. What is a derivative again? Slope, right? Slope, slope, slope. What's the derivative of a horizontal line? 0. So that makes sense that way. And then the power rule way, there would be an x to the 0 power sitting beside that. Right. And 0 times anything.
Is the fourth one on the left x to the 2 over 3?
Yeah, Drew.
It is x to the 2 over 3. Yeah.
Really? I'm really happy that we got
Me too. Me too.
Will you do the first one?
I'm going to do them all.
Slowly.
Yes. So, let's start at the top. Wait, we could use the power rule, or we can use logic on the first 4. You have options. Both options work. Power rule works. Logic works. Is it important to know what a derivative is?
Yes.
And what is a derivative? Slope, right? So, would you agree that these two are both horizontal lines? So what is the slope of any horizontal line?
0.
Okay, now let's also talk about the power rule, because it works too. If we really understand exponents, would you agree that this is 5x to the 0 power? No, you would never write that. That would be silly, but it is. And what's 0 times 5? 0.
So why would you have to try 5 to
You would write 0 times 5. X to the negative 1, but what's 0 times anything? So it makes the whole thing go away. Which makes sense because a constant slope should be 0. What should the slope be on a line? Negative 5, the m. Would you all agree with that? Okay, let's see if the power rule works for us. This is a first power, would you agree? 1 times negative 5 is negative 5. You'd reduce the power by 1 and get x to the 0 power. What is anything to the 0 power? 1. It just, you're not going to write it because you wouldn't write times 1, right? So it works. But, do you really want to have to think this hard on either one of these? So it's probably a good idea to memorize the derivative of a constant is, and the derivative of a line is the slope. Probably the fastest way to do that. But either way works.
So how is x to the 0 not 1?
X to the 0 power is 1.
How is x
When you have
5?
power, you gotta.
It's not. Which one are you doing? Are you doing this one down here or this one up here? Okay. The derivative is 5 times 0, x to the negative 1. right? You keep forgetting to bring the power down. And what's anything times 0?
0.
Does that make sense now, Drew? Now, again, that is way too much work when we know the derivative of a constant 0 because slope is 0, right? So that's too much work, but essentially derivatives, any constants are 0. Okay, let's look at the next one. These will be easier for you, which is, isn't it funny? Mental note. Remember yesterday when we did these, how easy they were, or 2 days ago? Because you were thinking slope 2 days ago, right?
Uh-huh.
And remember how easy they were? And then this one was hard, right? Well, today, some of you are making these top 2 hard. So go back to Monday's thoughts to do the first 2. They're just the slope. So the slope of a constant is 0. The slope of a line is the slope, the m. This one, power rule, 3 times the 2 is?
6x.
Minus
Very good. Any questions about that? What about the next one? Okay, I want to slow down. Is anyone not seeing these patterns? 3 times the 4 is the 12. Take 1 away from the power. What? The negative 7 is just negative 7. And then what happened to the 5? It went away. Remember, all the constants are going to be 0. Does that make sense? Who needs me to explain more? Or which one?
Oh,
Pick one.
the one you just did.
Okay, so the 3 times the 4, you bring the power in front.
Okay.
That gives you the 12.
Okay.
And then 3 minus 1 is 2. This is negative 7x.
Right.
So this power is 1. 1 times 7 is 7. X to the 0 power, which we know is just 1, so we just won't write it. And then what happens to all constants? Okay, x to the 2/3. Two-thirds. X to the... Where in the world did negative 1/3 come from?
Subtract 1.
I subtract 1 from 2/3. So, yes, it was x to the 2/3 power was the question. 2/3 comes in front. Negative, I subtract 1 from 2/3, which gives me negative 1/3. Quick mental note. This is a cube root squared. How hard would that be?
Very.
Quite challenging if you had to do that the long way, wouldn't it? It'd be pretty awful, wouldn't it? Now, it's tempting to tell me that the power rule is hard. I just want to keep reminding you what it's replacing. It's not bad. Not too terrible.
So are you just going to leave it as x to the negative 1?
Sure. If you want to write it as 1 over cube root of x, you can. For today, my biggest question is, can you do the derivative? If it says simplify, then do it. What do I need to do to this one to be able to use a power rule? I need to know that that's x to the 1/2.
But you don't have to move that one to the point. I can use it like that.
This one? Either way. It would be correct either way.
So it'd be 2 divided by 3x to the 3rd.
Yep. Or 3 times the cube root of x if you wanted to write that. F prime of x is 1/2 x negative 1/2.
How are you getting the x?
So this power was 1/2. I'm going to subtract 1 from that. What is 1/2 minus 1? Do you,
Are we not doing this the same as the ones on
Yep.
top?
we are. So the power here is 1/2. We move it in front, and then subtract 1 from the power. Now at the top, when you subtracted 1 from the power, you didn't think a whole lot about it. 3 minus 1 is 2. It was easier to do in your head.
Oh.
But that's what you were doing, right? So we're still doing that. It's a fraction of subtraction, but other than that, we're still doing the same thing. And yes, if you wanted to rewrite this, it's 1/2 square roots of x. Now here's where this gets yucky. I have no rule for division, and I have no rule for multiplication. I must use algebra first. Yes. I don't want a common denominator. I just want to divide. But it's been a while since you did properties of exponents, so we need to talk about it. Now, before you tell me it's hard, let me remind you what we're replacing. Imagine an x plus h in the place of all of these x's. Yeah. Okay? I'm not going to do that. Okay, what I am going to do is rewrite using exponents. What is a cube root rewritten? X to the 1/3. How do you divide two things with exponents? You subtract them, right? So, would you agree f of x equals, what's 1/3 minus 2? Negative 1 2/3, which is?
Negative 5/3.
So, 1, really? Okay, side note, 1/3 minus 2 is what we're doing.
You multiply that and get 6 and then subtract 1.
So negative 5/3, does everyone agree? Plus, I don't want any denominators, so I'm going to write 5x to the what? If it had been written like this originally, would this have even been a hard problem? No, so what's the hard part about this problem? The algebra. It's not, the calculus here is easy. Calculus generally is the easy part, and I know you probably don't believe me on that, but
I don't.
what was the hardest part of limits?
The limit? No. The limit?
Taking the test.
Size of the limit.
The limit part was easy, you just plugged in a number. What was the hard part?
Whenever you got 0.
The algebra was the hard part, right? Algebra is the bad subject. It's the hard part. Calculus is the easy part. Okay, so f prime of x would be, what would it be? Negative 5/3. Where'd you get that? Move the exponent to the front. X to the what?
Negative 8/3.
Negative 8/3. And how in the world did you get negative 8/3?
Subtracted 1.
Minus 1, which is 3/3, right? So negative 5/3 minus 3/3 is negative 8/3. What about the second piece?
Negative 15x, negative 4.
Devin, is that making sense? Okay, the 3 times the 5 is the negative 15. Stay with me, don't let yourself get lost. It's not bad. Negative 3 times the 5, negative 15. And then I'm going to x, and I'm going to subtract 1 from negative 3. What is negative 3 minus 1?
Don't you mean negative 4?
That's what they said. Devin, does that make sense?
Yeah.
Really?
Yeah.
Okay, good. Okay, any questions about that one? What am I going to have to do to the next one? Good. This one. Okay, I can't work it as it sits. I don't have a rule for a product, but I can just multiply. So I can FOIL or distribute or whatever word you want to use.
So it's x.
Okay, what is x to the negative 2 times x cubed. How do you multiply?
Adding.
You add the exponents. So x to the negative 2 times x to the 3 is x. Hey, if you've forgotten these properties, where could you find them?
The property sheet.
You have a properties of exponents note card, don't you?
Google.
Or Google, yes.
Always trust Google.
Minus 7x to the negative 2
plus
plus x
x cubed
cubed
minus
minus 7. Okay, any questions about how I got that part? F prime of x would then be, what's the derivative of x?
1.
Why 1?
That's x to the 1.
Because that
Good.
is 1 power.
Good, so that's 1 minus 1 is 0. Anything to the 0 power is just 1, so it's just 1 times 1. What about the next piece?
Plus
14
x to the negative 3.
Okay, where's negative? Plus,
Negative 2 minus 1.
plus 3x. Always forget that part.
Plus 3x squared. And then what happens to the 7? Disappears. Okay, we're going to do two more bad ones. Now, the only way I can make these bad at this point is by making the algebra a little yucky, right?
Oh, yeah.
Otherwise, the rule's the same. What's a negative 1 power do?
Flip everything.
Flips everything. So 3x to the 4th minus 2x
You got it, Devin. You're learning.
over 4x cubed.
This is the last slide.
I don't know.
We have 18 more of these exact same.
I think we should watch the video.
Or staying after lunch to learn.
You'll be okay. I think you got the gist. We're just doing some.
But I think we need another day to go over this.
Okay, can I deal with a denominator?
Yes.
Factor 9,000.
How? What do I do with that?
Separate.
Drop the negative 1.
Factor it.
Factor of x.
I flipped it.
Factor.
X. I
I
don't
want
know.
to factor it.
I could, but then it makes a multiplication. I don't want multiplication either.
Oh, how to factor it. Factor it.
Find the 4x by 3 over
Right,
6.
tell her to factor it. She'll do it, I promise. So,
No, I want to divide. I want to divide both pieces by 4x cubed. No, not even that. Easier than that.
Synthetic division.
No, like just divide.
I have been telling you since the beginning.
sorry. I think honest, right?
Just divide.
What happened?
It blew up.
So I'm doing 3x to the 4th divided by 4x cubed.
I don't think you could do that. Just minus or plus.
Well, you tell me, is this equivalent? Fractions with common denominators, can I put that together and be one denominator?
Yeah, probably.
Now, you cannot split a numerator, but you can split a denominator like that. So be careful. If this had been the problem without the negative 1, I couldn't have done that problem yet.
So it's 3 plus x to the negative 3rd.
Okay, so Devin, you see how this splits up? And then I just divide. The 3/4 just stays 3/4. X to the 4th divided by x cubed is just x. And then 2/4, which we could write as 1/2. X to the 1st divided by x cubed. How do I divide? Don't I subtract exponents? 1 minus 3, which is negative 2. So f prime of x. Now we're to the calculus part. We're to the easy part now. Yes.
3/4 minus x to the negative 30.
Plus.
Oh yeah.
The negative 3rd.
X to the negative 3rd. 1 over x squared.
Hey, any questions about that one? Quick question. Calculus, would you agree, is the easy part?
No.
Yes.
Calculus is the easy part.
I agree.
I feel like you're just making it now.
No. Calculus is the easy part. Algebra is the hard part. X to the negative 1. Write that one down. We're gonna work that next one.
Wait, no, was it ready?
Yeah, mini.
It is not that bad.
Go back up.
The algebra is slightly difficult. But you did these algebra things in Miss Lowe's class. Be careful. Don't just flip everything. Why can I not just flip everything?
Because we don't have to denominate.
Why can't we?
What'd you say? I heard someone say it. There's subtraction in between. We can't just flip things with subtraction in between. But the negative one went with everything. So no, this is a new f of x. Goes over x to the negative 2. Hey, if y'all would be quieter, you would learn a lot more instead of whining and complaining.
Negative x minus.
Hey, can I divide both pieces by that denominator, though? Yes. So f of x is negative 1 minus negative 2. What is negative 1 minus negative 2? Why 1? Good. Minus negative 2 is like adding 2. So I get x to the first minus negative 3 minus negative 2. Wait, this is f of x. I'm dividing both pieces by x to the negative 2. F prime would then be what?
1.
Yes?
1 minus 1 plus 1, so it'd be.
Okay, what's physics?
Okay.
Negative 1 minus 1.
Yes. Okay, we'll talk about that tomorrow.
Why?